Polynomials test prep, 20 problem review, unedited video. Here we go. Let's get math-isfied. Problems 1, 2, and 3, your instructions are simplified. 8x minus 9x squared plus 3x to the third power minus negative 3x cubed minus x squared plus 8x. This is a subtraction problem, so distribute the negative sign to each term. As I change these, I'm going to align them with the common like term. This will become positive 3x cubed. Let's put that here. This will become positive x squared. Let's put that here. And we have negative 8x. X minus 8x 0, negative 9x squared plus x squared will be negative 8x squared. And 3x plus 3x will be 6x, and those are x to the third, x to the third. You see 6x to the third. That is problem 1, subtraction of polynomials. Make sure you distribute the negative sign. Problem 2. I'm going to simplify 7x minus 3, this binomial, raised to the second power. Second power, or squaring, reminder, you're multiplying the term or expression by itself, not times 2. 7x minus 7x, or 7x minus 3 times 7x minus 3. When we expand it out, box method, FOIL method, or just distributive property. 7x must be multiplied by 7x. That will give you 49x squared. 7x must be multiplied by negative 3. That's negative 21x. And the other two multiplications will be, I'm working these markers and color coding. Negative 3 times 7x is negative 21x. Negative 3 times negative 9 is positive 9. The like terms that will be combined are negative 21x and negative 21x. That will give you negative 42x. Bringing down 49x squared. Bringing down a positive 9. And we have multiplied 7x minus 3 to the second power. Problem 3, the third of the problems we simplify, will be 3 terms that need to be multiplied together. 3 factors. 3n minus 3, n plus 3, and n minus 3. Now what you do is begin with any 2 of these factors and multiply them together. Same process previously. So I'll just begin with the first 2 terms. Actually, I'll begin with the second 2 terms. I see a difference of squares, the last 2 terms. N plus 3 times n minus 3 simplifies to n squared minus 9. Now that needs to be multiplied by the first term. If you choose to factor out the 3 to simplify this for yourself, your multiplication, you're welcome to do that. Okay, 3n times n squared. Let's bring it up over here. 3n cubed. 3n times negative 9 is negative 27n. Negative 3 times n squared is negative 3n squared. Negative 3 times negative 9 is positive 27. I actually followed the same process for the 4 multiplications here. Look for terms that can be combined. This is n to the third, n, n to the second, and 27. You do not have any. all you can do is rewrite this. Standard form, 3n to the third minus 3n to the second. We have decreasing exponents. Minus 27n plus squeeze 27. That's problem 3. Catch your breath. Let's erase and move on to problem 4. 4 through 7 will be factored completely. I don't have the speed erase. I don't have the fancy editing tool. Make this look all magical. Let's go 4 through 7. Factor completely. I always consider factoring to be the #1 skill you need at the Algebra 2 level. Okay. 16a to the third minus 48a to the second minus 25a plus 75. First, look for the greatest common factor, your 4 terms. 16, 48, 25, 75 do not have one. Each term does not have an A. There's no greatest common factor. Next, because you have 4 terms, you want to consider factoring by grouping. Let's look at the first 2 terms. Factor out the greatest common factor, focusing on the first 2 terms only. There's a 16 and an A to the second that factors out, leaving a minus 3. Distribute to check. The last 2 terms have negative 25 in common. That leaves an a minus 3. Distribute and distribute to check. Next, you will have a minus 3 as a factor here and a minus 3 as a factor here. That needs to be factored out. This beginning is left with 16a squared. The back is left with negative 25. Last, look at 16a squared minus 25. It's the special binomial. Is the difference of squares. I will factor into 4a, because 4a is the square root of 16a squared, minus 5. 5 is the square root of 25. And this will be times 4a plus 5. Don't forget about your a minus 3. And now this polynomial is factored completely. Number 5, I think we can work in over here. X to the 4th minus 625. X to the 4th minus 625. Okay, we have a special binomial. We have a difference of squares. X to the 4th will factor into x squared. 625 factors into 25 times 25. That's the square root of x to the 4th. That's the square root of 625. Need a minus and a plus. Subtraction and addition. Here we have another difference of squares. 25, square root of that is 5. 5, we need a negative and a plus. You can put your plus, then your negative in that order. Order does not matter with multiplication. Commutative property comes into play. And don't forget your x squared plus 25. You're welcome to stop or pause the video at any time to review anything I share with you. You know I'm talking fast. I want to make this as condensed as possible. All right. Number 6. Let's try here. I edited. I may flop on this. Okay, 5x to the 4th plus 14x squared minus 3. Okay, this is unique. We have a trinomial, but the highest exponent is 4. We can factor this into 2 binomials initially when we see that this degree is twice this degree. And there's no variable here. So, stay with blue. Oh, we'll go to black. 2 trinomials, two binomials, excuse me. What's going to give us 5x squared? 5x to the fourth, 5x squared times x squared. Now, what multiplies to negative 15 and adds to 14? That's what we're looking for. Okay, so let's back up and use grouping for this because I did not pay attention to the a value of being 5. A value is 5. So what multiplies to negative 15 and adds to 14, positive 14, it's going to be a negative 15 and a positive 1. So we break up this middle term into negative 15x squared plus 1x squared, bringing the front and the last terms down. Now we have the same polynomial, but we have 4 terms to represent it. We're going to factor this as we did with problem 4 by grouping. First 2 terms, we'll factor out a 5x squared and leave an x squared minus 3. The second 2 terms, factor out a positive 1 and leave an x squared minus 3. With factoring polynomials, positive 1 and negative 1 have to be considered. Now, both of these have x squared minus 3, which cannot be factored further, but it's factored out. That leaves 5x squared plus 1. Number 6 is now factored completely. Let's move ahead to number 7. Last one with factoring polynomials. Okay, looks like 125 x to the third, 125 x to the third minus 8. We have a binomial, so we have to consider, is this a difference of squares, difference of cubes, or sum of cubes? First, factor out the greatest common factor, as we always attempt to do. There is none. 125 is a perfect cube, x cubed is a perfect cube, or x to the third is a perfect cube, and 8 is a perfect cube. Separated by subtraction, we have a difference of cubes. Using the format a minus b, a squared plus ba plus b squared as your basic format for a difference of cubes. We let a equal 5x because that will give us 125x cubed, and we let b equal 2 because 2 cubed is 3. Just fill those in now. 5x, again, 5x cubed is 125x cubed. Cubing times itself, 5x times 5x times 5x minus 2. A squared will be 25x squared. B times a will be 10x. And b squared will be 4. This is factored completely. Because this is the format, or the factor, one of the 2 factors in the difference of cubes, you know you can't go further. This will not be factored further. All right, let's catch our breath. That is 4 through 7, which were factored completely. Now we're going to look at in behavior of a polynomial on problem number 8. Going to get into a lot of graphing for the remainder problems. 20 problems total. Test on the topic of polynomials. Okay, determine the end behavior. Here's the function. Call it f of x. Have negative 2x to the 7th plus 2x to the 4th. It's becoming more of a challenge for me to memorize more than one term at a time. Plus 8. All right. In behavior, the first thing I look at is the degree. And the highest degree is 7. That's odd. The ends will go in opposite directions. Next thing I look at is this negative. That negative tells us that the right end goes down. Negative, the right end goes down. Positive, the right end goes up. You could look at this first and reach the conclusion that the right end goes down. And I believe I stated that in a previous video. So the right end goes down. And because this is odd, the left end has to go in the opposite direction. That's the end behavior. How do you write that? For the right end, x is approaching infinity, and f of x going down is approaching negative infinity. For the left end, x is approaching negative infinity, and the function is going up or increasing. It's approaching positive infinity. Let's put plus signs with our infinity for positive infinity. Not necessary. All right, so that was number 8 out of 20. Talked about in behavior polynomial. Number 9. This is going to be divide with long division. 4x cubed minus x squared plus 1 divided by x squared minus 6x plus 1. I'm going to write the problem, then we'll set it up. 4 x cubed minus x squared plus 1. Dividend, divisor, x squared minus 6x plus 1. All right, now let's do the long division. Dividend on the inside, divisor on the outside. Look at the first term of the dividend compared to the first term of divisor. 4x cubed over x squared, that equals 4x. Put that up top. Where you put it is irrelevant. Your choice. You can put it to the left, put it above x if you had one. That brings us to the point. We are missing an x value. So let's fill that in. So we have x cubed, x squared, x value, then a positive 1. So plus 0x plus 1. Problem was selected intentionally by your teacher to see if you catch that. Now, 4x gets multiplied by each of these terms and the result is placed underneath. Of course, this has to be 4x cubed. We did the work here. Minus 24x squared plus 4x. The math operation, as you recall, in long division with numbers is a subtraction. That will always cancel. Negative x squared minus negative 24x squared will be 23x squared. 0 minus 4x squared will be negative 4x. And 1 minus nothing will be 1 minus 0 will be positive 1. Now we look at the first term of dividend compared to the first term of the divisor, which will always be x squared over here. 23, get us 3 in there. Say 23, I need to write 23. 23x squared divided by x squared is 23. So positive 23 goes up top. And then we're going to multiply the 23 by each term in the divisor, put the result underneath. It'll give us 23x squared minus 138x plus 23. 23x squared minus 138x plus 23. What's the math operation? Subtract. Carefully distribute your subtraction sign. First term cancels. That has to happen. Negative 4x minus negative 138x will be 134x. 1 minus 23 will be negative 22. That is your remainder. This degree is less than that degree, so you stop there. Your answer also is written as 4x, so your answer is a quotient, plus 23. This is positive, so plus 134x minus 22 over your divisor, x squared minus 6x plus 1. All right, that was a division problem with a polynomial. Long division. Sorry about the close-up. Next, we need to look at, and this brings us to the halfway point problem-wise, problem 10. I'm going to look at a function. I need to sketch it for you, and then we'll see if the degree is even or odd and find the equation associated with the polynomial. Okay, sketch graph. I'll try to make the key features accurate, distinguishable. Y-axis, x-axis. They extend to infinity in both directions. Okay, we're going to have an intercept at negative 3. We're going to have an intercept at positive 3. And we have intercept on the y-axis at negative 5. Sketch this here. Coming down, up. Okay, degree even or odd. The ends are going in opposite directions, so the degree is odd. Degree odd. Left end is going up, right end is going down, or left end, if it goes down, and right end goes up. Now, let's find an equation. I'm going to start with factored form. Excuse me. Try to get this one finished before the battery dies. One factor for the x minus 3 is going to be x plus 3. We're going to have a factor for x plus 3, or x equals 3. It's going to be x minus 3. Because it touches and turns, it has a multiplicity of 2, or in general, an even multiplicity. Our a value is going to be negative because the right end goes down. We know we need a negative. Now, probably the most challenging part of this is determining the actual a value. Our y-intercept equals negative 5. 3 times negative 3 times negative 3 times negative 1 gives us negative 27. So to actually get a negative 5, we need 5 over 27. And that will give us our polynomial function for this graph. I'll have to make a part 2 while I charge my battery. Thanks for watching. Please comment with any questions you have about any information I provided you.